We're going to use definition of the derivative to compute f prime of 2 if f of x is equal to 3x squared minus 4x plus 12. We cannot use rules of differentiation to solve this problem. I'm going to use three different methods to find f prime of 2, and you decide which method works best for you or the easiest to understand. The first method, we're going to compute the derivative first. So f prime of x is equal to, recall, the limit as h approaches 0, f of x plus h minus f of x divided by h. So let's go ahead and compute that. First we'll compute f of x plus h. That means replace every x in the function with x plus h, and make sure you put that in parentheses. So this is 3 times x plus h squared minus 4 times x plus h plus 12. And this is 3 times x squared plus 2xh plus h squared minus 4x minus 4h plus 12. Now this can be further simplified. F of x plus h, we expand this, multiply by 3, becomes 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 12. Now let's compute the difference between f of x plus h and f of x. So f of x plus h minus f of x is equal to 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 12. Let's subtract f of x in parentheses. 3x squared minus 4x plus 12. Now when we cancel, everything without the h should cancel. Here's 3x squared minus 3x squared minus 4x minus a minus 4x. That's 0. 12 minus 12, that's 0. Only thing that survives are, the only things that survive have h factor. So we can now factor in h out. And this is 6x plus 3h minus 4. And that's the end of this step. The next step is to divide f of x plus h minus f of x by h. So let's do that. F of x plus h minus f of x divided by h equals h times 6x plus 3h minus 4. Divide that by h. You can see that the h is canceled. That's exactly what should happen. That leaves us 6x plus 3h minus 4. And the next step is to compute the derivative. F prime of x is now the limit as h approaches 0 of the difference quotient, which is 6x plus 3h minus 4. Notice that h goes to 0. X is not affected. 3h goes to 0, and that leaves 6x minus 4 as our derivative. And now we can answer the question. We had function f of x, which is 3x squared minus 4x plus 12. We found its derivative to be 6x minus 4. We wanted to compute f prime of 2. We can now plug that into the derivative. 2 times 6 is 12 minus 4, and so the answer is equal to 8. F prime of 2 is equal to 8. So this is method number 1. Method number 2, we still use the same definition of the derivative. Remember, f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. But now, instead of waiting to plug into at the end, we plug into at the beginning. So f prime of 2 is equal to limit h approaches 0, f of 2 plus h minus f of 2 divided by h. So now we have to evaluate this limit, and once we're done, we'll get a number, not a function, and that will be the derivative of this function at x equal to 2. So f of 2 plus h is equal to 3 times 2 plus h squared minus 4 times 2 plus h plus 12. So that's 3 times 4 plus 4h plus h squared, and then minus 8 minus 4h plus 12. And this is 12 plus 12h plus 3h squared minus 8 minus 4h plus 12. So we have 12 here, that's 24, minus 8, that's equal to 16. We have 12h minus 4h, that's plus 8h, and plus 3h squared. So that's f of 2 plus h. F of 2 is 2 squared is 4 times 3 is 12 minus 4 times 2, which is 8, plus 12, so that's equal to 16. F of 2 is equal to 16, and now we can compute the limit. F prime of 2 is equal to the limit as h approaches 0. F of 2 plus h, which is 16, plus 8h plus 3h squared, minus f of 2, which is 16, and this is divided by h. So all we have to do is evaluate this limit, and we have our answer. Here 16 and 16 cancel. We have 8h plus 3h squared in the numerator. When we divide that by h, we end up with the limit as h approaches 0, 8 plus 3h, and let h go to 0, we end up with f prime of 2 is equal to 8, exactly as we had using method number 1. Now let's do the same thing using yet a third method, which is method number 3. Method number 3 uses slightly different definition of the derivative. It's of course the same thing, and it's this: f prime evaluated at number a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. So in this case, a is equal to 2. So f prime of 2 is equal to the limit as x approaches 2, f of x minus f of 2 divided by x minus 2. Now recall, we already computed in the previous, in step 2, that f of 2 is equal to 16. So let's plug that in, compute the limit, and you'll see we also will end up with 8. F prime of 2 is equal to limit x approaches 2, f of x, that's 3x squared, minus 4x plus 12, minus f of 2, which is 16, divided by x minus 2. And this is equal to the limit as x approaches 2, 3x squared minus 4x minus 4 divided by x minus 2. Now if we plug in 2 for x, we'll get an indeterminate form, 0 over 0. So that means we have to factor the numerator. Limit as x approaches 2, the numerator can be factored into x minus 2 and 3x plus 2 divided by x minus 2. Here's the source of 0 over 0. X minus 2's cancel. We're left with the limit as x approaches 2 of 3x plus 2, and of course that limit is equal to 8, and that's the derivative of this function at x equals to 2. Using these three different methods, you can decide whichever one you like the best. They arrive at the same conclusion.